Good morning. Um Myself, Shruti Joshi, and I'm doing my main project as analysis, fabrication, and testing of battery cells for underwater torpedo. So, let us know what's a torpedo. Torpedo is a self-propelled weapon, also a vehicle with an explosive warhead launched above or below the water surface, propelled underwater towards a target, and designed to detonate either in contact or with its target in contact with its target and or proximity to it, that is nearby it. There are types of torpedoes based on construction. There is lightweight, heavyweight, based on the path taken to chase either direct motion or projectile motion target, based on the medium, either underwater or aerial torpedo, and based on the detonation method, that is contact detonation or proximity detonation. So the work what I did in this project was based on the battery compartment which lies in the center of the torpedo, which is as shown here. And next, so my objectives were for to model the battery cells, do non-linear static structural analysis for all the forces rising on the battery cells, and then do check which material would be better for the battery cells, and then based on that design mandrel if it is either CFRP or GFRP, and if aluminium is considered then it's manufacturing or fabrication feasibility. Then conformance testing of my fabricated cells, whichever it might be GFRP, CFRP or aluminium, whichever by the trade-off matrix, whichever was better, that one. So moving forward, this was my methodology of the project. I have done the nonlinear static analysis in ANSYS workbench version 18. So moving on next, this would be the battery shell assembly of the torpedo in detail, and this is how the model looks like. And now coming to the analysis procedure, this is how we import the model into ANSYS workbench and then set initial contact informations uh, for every contact which is in the assembly, then details on meshing because every part of the body needs to be meshed, and then these are the forces which are arising on the battery cells for which the battery will be undergoing the way it behaves, each material with either aluminium or CFRP or GFRP. So this will be the setup. Now we'll be discussing some results on based on the total deformation using aluminium material. This is the equivalent stress which is being formed. This is the total deformation of battery. This is X, Y and Z axis deformation. Similarly with respect to carbon fiber, total deformation, equivalent stress on the battery, X, Y, Z direction. Similarly, material is glass fiber reinforced polymer, that is GFRP. Then it's the total deformation what we are getting. Then equivalent stress, total deformation, x-axis, y-axis, z-axis. So this is the non-linear static analysis result for all the three parts. So based on this this one Excel file, we come to know that GFRP is the part which will be eligible for getting manufactured because of very good factor of safety which it provides, and very less equivalent stress which is being developed is very less. It's 110 MPa. So we'll be discussing on the mandrel design. um, so this is the type of the mandrel. Ours will be solid split mandrel. It's a solid split mandrel. And then these are the drawings for assembly, whole of the assembly. This is battery section. This is the hollow left mandrel, right side mandrel with support plate and puller rod. These are the fabricated mandrel cells. We even did stress analysis, equivalent stress developed on the mandrel, and it was found that for every 10 MPa of tension by the filament, the stress developed by the on the part is 112 MPa. Then total heat flux is this much, and then what the directional heat flux, and these are the references. So guys, this is my project. Thanks for watching.